We'll proceed in summation to integral calculus. Okay, very deep discussion we are doing in summation to integral calculus. Can we bring integral calculus from summation? What is the idea behind summation? What is the idea behind the summation? Is we can divide our problem into many sections. We can divide our problem into many sections and then then calculate solution for each section, each division, and then sum it. That is summation. Okay, if I have a problem, divide it into many parts. If I have a problem, divide it into many parts. Solve the problem part by part and then add the solution. Okay, and that is called summation. But what is the problem in the summation? The problem in the summation is if I divide into 4 part, 5 part, I can sum it. But if I divide into n part where n tends to infinity, then it is difficult to sum it. Anyway, now then we saw that how we can proceed upon calculating the kind of okay, every time we go do the discussion with the circle. Okay, how to find kind of circumference of a circle. If I say how to find circumference, because this is the basic unit. How to find circumference of a circle. How to find circumference of a circle. More or less, I am saying how to find length of a line. This is circumference of circle is nothing but length of a line one. Simple line. How to find length of this line? Then I can cut this line. I can cut this line into n section and calculate length of each section and add it. Okay, this line can be in this form also. That's it. Generally, people think circumference of circle. My God, it is very difficult because isn't it? It is a round shape and very weird. So how we can calculate circumference of the circle is nothing but it's a line only. Both ends are connected to each other. That's it. Otherwise, it is mere a curved line. To calculate the circumference of a circle, then we cut it into so many parts. Each part we try to calculate the length and then we add it. Consider from here to here, I have to find a length of a curved line. If I have to find length of a curved line, then I am going to cut it into n parts. This is first part, second part, third part, fourth part. This is ith part. And then, and like that, this is the nth part, last part. Last part, this is ith part. This is first part. That is the scenario. Now, how we go along with calculating the length of a line is then I'll say what is the length of the section that belongs to ith part. If I say that is L, Li, L is capital L, bottom right I. Ith section of this length is how much? I'm trying to calculate length of this curved line from begin till end. Rather than calculating the length of this curved line through some meter or tape or something like that, I'm going to divide into n parts. Each part I'm going to calculate the length. Why it is so? That we will see. Because it is easy now. Since it is curved, it is very difficult to calculate the accurate line like this. So I have a mischievous brain. What is mischievous brain is if I cut into n number of parts, then each part will look like a straight line because it is very small, right? If it is very small and it will look like a straight line, then I can just calculate all the straight line and just add it and say this is the length of the line. Makes sense? If I take a straight line from here to here, then I say what is the length of the line? What is the beginning point? This point. What is the end point? This point. What is the length of the line? This point to this point. Just calculate the length. No, no, no. It is not. Okay, let me divide it to two parts. Okay, now calculate length from here to here as a straight line and here to here as a straight line. Yeah, it is better. Okay, let's calculate it into 4 parts. Let's calculate into 10 parts. Let's calculate, okay, let divide into 10 parts from here to here, 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 10 parts. Now calculate all the straight lines. Then it will be near to the actual length. Okay, understood what is the concept. Now divide into n different parts where n tends to infinity. Now calculate all the straight line and it will be, since it tends to infinity and each length tends to 0, if you calculate the straight line length also, then it will be straight line length also, then it will be kind of it will be near to the actual length. What is the ith section length? If this is the first section, second, third, ith section and nth section, what is the ith section length? That is under question mark. What is the ith section length? What is the net length? The summation of I equal to 1 to n length of ith section. If I, okay, is it required that all the section length are same? Not required. Okay, still now we can say L1 plus L2 plus L3 plus Li plus Ln, length of the nth section. This full length is the actual length. What is the length of the ith section? That is under question mark. This is the first bottleneck. How to find length of the ith section so that I can generalize later for the full section. That is the biggest hurdle. What is the length of the ith section? What is the length of the ith section? Okay, that is the hurdle that we will try to get away from our length vector concept that we had brought some time back. Something is called a length vector. What is right now available? Right now available, like let's consider that now the length of the ith section depends upon scenario to scenario. Okay, what is the length of this ith section? Anyone will ask, what is the length of this ith section? Okay, I know length of this ith section. What it is? Tell me. Okay, this is the ith section. Means here there is a point. This is x-axis and this is y-axis. This is x-axis and this is y-axis. What is the length of ith section? Okay, I know what is length of the ith section. Okay, tell me what is the length of the ith section. Now, here, if it goes on x-axis, it marks a point as x1. From here to here, if it goes on x-axis, it marks as point x2. What is x2 minus x1? I said delta xi. Delta x is the width for the ith section. Similarly, any section, if I want, what is the length in x along x-axis? If I take third section, then it is delta x, third section. Okay, but all delta x are same, not required. Certainly not required. How come it is not required? I divided this line into n parts. If I take here any section, the length on the delta x will be very small. If I take here, then delta x will be large. Makes sense? So I have not chopped x-axis into n part. I have divided this line into n part. So if I go along x-axis, then all the delta x will be different for each section. For each section, all delta x will be different. Understood? Understood. What is the length of this section? Ith section. Considering this is a straight line, this is the problem. But anyway, this is what we have been talking about, the repeated summation that later we go into integral calculus. Repeated summation. When we divide our problem, what is your problem? Problem is to calculate the length of this line. To calculate the length of this line, the problem is that, and for solution is I divide into n part where n tends to infinity. Okay, thank you very much. N tends to infinity. Understood. Okay, now if I'm trying to calculate any ith section, first section, second section, third section, ith section, n minus 1 section, n section. What is the length of this ith section? Considering this ith section is a straight line, since n tends to infinity, this ith section is very small. I consider as a straight line rather than a round line. Straight line. Then take what is the intersection or interception coming on x-axis? That is delta x. Delta x of the ith section. What is interception on y-axis? Delta y of the ith section. Then this is the hypotenuse of a triangle. Looks like. If I take any ith section, this is delta x and this is delta y. This looks like hypotenuse. Okay. This is delta x, this is delta y of the ith section. What we are talking is this line. This line is a hypotenuse to this right angle triangle because x and y are at 90 degree to each other. That is understood. Okay, in that fashion, the length of is section is delta xi whole square plus delta yi whole square of the is section, the square root. Okay, this is the length. Now let's calculate the length of this curve. Summation I equal to 1 to n. Summation I equal to 1 to n. Delta n 1 to n length of the ith sector, that is square root of delta xi whole square plus delta y ith section whole square root. That is okay. Thank you very much. Okay, now I have to proceed calculating it. How much is the length at the end? Square root of delta x of the first section whole square plus the square root of delta y of the first section whole square root plus the square root of delta x second section whole square plus delta y second section whole square plus the square root of ith section whole square plus the square root of I'm sorry, the square root of delta x of the ith section whole square plus delta y ith section whole square plus the square root of delta x of nth section whole square plus delta y of nth section whole square. This will give the net result. What it is, I don't know, but this is what it is. Okay, so first step is to find the generic way to get the ith section length. This is a generic way to get the ith section length. Delta x whole square plus delta y whole square of the ith section, square root. Okay, then someone has to proceed in that fashion. What it is, I don't know what it is, but this is how it is. Okay, let's take in this is what we have talked little earlier in the same series as summation to integral. Anyway, now means this is what we are discussing. So now I'm going to close this end. I'm going to close this end. Okay, if I close this end, nothing is going to change. It will be same thing. Summation I equal to 1 to n square root of delta xi whole square plus delta yj whole square. Okay, this is how it is. But if it is a circle, then I can, now we have two components, delta x and delta y. I want in one component. Okay, then what about converting x to r cos theta? Because this is a circle where radius is constant, radius can move like so. Converting it to polar coordinate system where x equal to a cos theta, a is constant and it is moving like this. Radius is moving 2 pi angle. So x equal to a cos theta, y equal to a sin theta. Okay, whatever it is. This is how it is. Anyway, we will proceed. So how we can proceed now? Okay, first of all, this summation. So before going there, now this is what we have received the summation. Now I can go with any. There are many ways to proceed here. One way I am going to talk. There are many ways to proceed here. Okay, what are many ways to proceed here? One way to proceed here is the converting into polar coordinate system, then proceed. Another is converting it to vector and then proceed. What is way of converting it to vector? Take out delta x. Take out delta x. Then it will become summation delta x is section square root of 1 plus delta y by delta x whole square. Makes sense? Now it will become summation square root of 1 plus delta y of the is section by delta x of the is section whole square into delta x of the is section. This can be written delta y. Y can be function of x. Makes sense? Like if it is a circle, then y equal to a square root of a square minus x square. If this is a straight line, then y equal to x square. It looks like it looks like that. It looks like that. Y equal to x square. So y and x are related to each other. In that fashion, delta y by delta y by delta x, per delta y by delta x means per unit change in x brings how many unit change in y, where y is function over x. Y by x, there are two things. One is y by x and one is delta y by delta x. Y by x means per unit of x is how many unit in y. Makes sense? Per unit of x is how many unit in y. Delta y by delta x per unit change in x. Change is a new word. Per unit change in x brings how many unit of change in y. Delta y by delta x. Okay, whatever it is. Delta y by delta x, where per unit change in x brings how many unit change in y, where y is function over x. More or less, it will come as a function of x only. So, summation I equal to 1 to n square root of 1 plus delta y by delta x of the ith section whole square will come as function over x only into delta xi. Okay, many times we have described this. This is more or less, if I have x-axis and there is a function over x, this is x-axis, then this is function over x-axis. Someone say y-axis also. This is x-axis, this is function over x-axis. There is a line, curve line, there is a curve line like this that is above the x-axis. This is called fx. Okay, what is fx? Dx, that is area underneath it. Whatever the area underneath is fx dx. Okay, in that fashion, this area underneath from point x equal to a to point x equal to b, whatever is area underneath it is integral sign x equal to a to b fx dx. Same thing I can rewrite as, now chop this area into n part. This area chop into n part. Take the ith section. What is area of the ith section? Then what is the height here? That is function over x, where x equal to this distance. This distance. Makes sense? Means distance from the origin till ith section. Function over x, that value, that height, into delta x, that delta x of the ith section. This is the area of this subsection. If I add all the subsection area, it becomes fx dx a to b. Makes sense? Same thing here. Summation of I equal to 1 to n. Summation of I equal to 1 to n. Function over x at x length is up till ith section. Okay, that is b minus a by n. B minus a by n. That is the that b by a minus n is the width of one section. If I say x, okay, consider a is 0 for simplicity. Then if I say x, then it will be b minus b by n into I. That is the x. fx at x, where x belongs to length till ith section. fx fx delta fx into delta x, that is the area of ith section. Fx is the height and delta xi, that is the width of the ith section. This will be area of the ith section. If I add all this sub area, then I get the full area. It is a fit case. We are adding, right? I equal to 1 to n. Fx delta xi. Okay, I add all the area, it becomes the full area. Okay, this is a fit case to integrate from lower limit of x to higher limit fx dx, because fx delta xi is the area of the ith section. If I add all these area through summation, it becomes full area only, that is fx dx. Makes sense? Okay, in that fashion, it will resolve as summation of x equal to minimum to maximum. If I'm talking as a circle, and if I take x as minimum to maximum, then it will give an fx, it will give the top area. This is what we are discussing. This is x-axis, and lower limit to higher limit will give the top area. But I know that circle is congruent along the x-axis. Then I will double it later. This is one way. So summation integration x equal to minus a to a, that is radius. I'm sorry, that is the radius minus a to a fx dx. What is fx? Fx is 1 plus delta y by delta x, delta y by delta x, where delta x tends to 0. It will is a fit case to become dy by dx. 1 plus y equal to square root of a square minus x square. Dy by dx is minus x by a square root of a square minus x square whole square. It becomes a square root of a square minus x square minus a square minus x square. Okay, up. Square root of 1 plus dy by dx whole square. That becomes x square by a square minus. It will become a by a square root of a square minus x square dx. Make sense? Okay, someone can proceed and he can calculate. He can up. What I did. Okay, okay. Let's proceed. We calculated. We are trying to calculate area or something like that. But we are trying to calculate the circumference. Will it give the circumference or area? Let's see. Okay, a by a square root of a square minus x square dx. X is minus a to a. A I can keep outside. 1 by a square root of a square minus x square dx. Integration is sine inverse x by a, where x is minus a to a. Sine inverse minus 1 to sine inverse 1. That will be sine inverse, hop. Sine inverse minus 1 is minus pi by 2. Sine inverse 1 is pi by 2. Minus pi by 2 to pi by 2. Makes sense? If I add these two, it will become pi. And outside we have kept a, pi a. So this is, through calculating the area, we are calculating the circumference, whatever it is. But this is how it is. Now for twice 2 pi a is the circumference or length of this line in this fashion, where equation of the line is y equal to square root of a square minus x square. This is the one way we saw. What is the other way? Other way, we change the y and x relationship into r and theta. If that is the case, then we have transformed it into fx fx dx, whatever it is. It came as integration of x equal to minus a to a, and then function over x dx. This is what we saw. Function over x is the square root of 1 plus dx by dy by dx. y equal to r cos theta, r sin theta, and x equal to r cos theta. Dy by dx is someone compute. It will be dy, if it will be, okay, it will be dy by d theta. If I differentiate with theta, dy by d theta into 1 by dx by d theta. Same thing. So dy by dx, so dy by d theta will be r cos theta, and here it will be r minus sin theta. Okay, r will go away and it will become a square root of 1 plus cos square theta by sin square theta. I believe it is all right. And it will become now sin theta will go up and it will become sin theta. It will sin theta dx. Dx will become now r sin theta. It will become r minus sin square theta. R minus sin square theta d theta. Someone can compute. We are not here. We are talking something else. What is problem with this approach? Okay, what is problem with this approach? Problem with this approach in our approximation lies in the straight line consideration. We are considering the ith part as a straight line. That is the problem. We started with the assumption that we cut our curve into n parts. That is, then we take the ith section, and length of this ith section is delta x square plus delta y square root. That will come as a hypotenuse here, and that here it is a curved line, but we think it is a straight line, and n tends to infinity. It works because integration works in that way, fashion. But what about, can I take this ith section arc as an arc, not as a straight line? Then is it possible? Then our length vector comes into the picture. Our length vector comes into the picture. What is the length vector? We have talked in very much detail in the previous section. What is the length vector? Length vector is a vector that is a algebraic vector. A vector that is algebraic vector, but not that simple algebraic vector. Calculus algebraic vector is a length vector that is not available in any of the book. Algebraic vectors are available in the book, like xi plus yj, xi plus sin xj. These are algebraic vectors, where component of the vector, ith component, jth component of the vectors are algebra. But length vector is not that much. It is calculus algebra. What is your calculus algebra and length vector? Okay, if I'm talking about length vector of the ith section, what is the length of this ith section? First, we will calculate the length vector, and then we will calculate magnitude of it. That will be length of this ith section. What is the length vector? Length vector, many times we have talked. Length vector is a vector that represents, length vector is a vector that represents a line as a length, line as a length. Like if I have, with length vector, we'll proceed these discussions now. So consider I have a line, this is x-axis, and there is a line like this. Okay, there is equation of a line. What is equation of a line? I know that is y equal to kx. K is a constant. That is the equation of line. Y equal to kx. Now tell me, what is the length vector of this? Length vector means, suppose I am trying to find distance of length of this line from point origin 0 comma 0 to a point called 1 comma k. 1 comma k. Equation of this line is y equal to kx, where k is constant. Y equal to kx. If y equal to x, then this is at 45 degree. Y equal to 2x, the way it will move. Y equal to half x, it will come down. Y equal to kx. I'm trying to find length of this line from origin to a point called 1 comma k. Okay, in that fashion, first I represent this line as a vector. Vector should be touching the line. This is what I want. It will touch the line. And if I consider this point as 0 comma 0 and this point at x comma y, many times I have repeated this, then the length of this line will, the vector representation of this line will be 0 comma 0 to x comma y is xi plus yj. Makes sense? 0 comma 0 to x comma y is xi plus yj. Length of this vector will be a square root of x square plus y square. But vector representation for this section from 0 comma 0 to x comma y is xi plus yj. Okay, so length vector we say is xi plus yj, where the magnitude of this length vector will be x square plus y square square root. Makes sense? Similarly, if consider this is not a straight line and this is a curved line. Okay, if this is x-axis and this is origin and this is any point x comma y, someone would be imagining this is the ith section we are talking, where begin point x1 y1 and end point x2 y2 is there. What is the vector representation of this curved line? What is vector representation of this curved line? If I say it is xi plus yj, this is what we are taking with delta x square plus delta y square, a square root. We are considering this as a straight line connecting these two endpoints. And this length we are taking by saying this is delta x and this is delta y. Whole square root. This will come at this line, not this line. What is this line equation? Okay, if I say this is origin and this is x comma y, then this line is xi plus yj. That is not a vector representation of this line. Why they are not same? Because if I take a straight line and this is x-axis, everywhere y by x is constant, a number, numeric number, and all are same. But if I take a curved line from here to here, every moment if I take y by x, any moment, if x equal to 10, then what is y? Y by x. If x equal to 2, what is y? Y by x. It will be variable. It will not be the same. Okay, means y by x is variable. It is not constant. In that fashion, both are different. So whatever vector representation we are making xi plus yj, if I am able to make it in representation of y by x, that is variable, then we are addressing the plane of a curved line also. What is the plane of curved line? Curved line can be represented it through vector, but plane of curved line is there must be expression in y by x because y by x is variable. If I say I have to represent a line where x is independent component, which is x is changing, then line equation must be in x because x is variable there. Similarly, if I have a curved line where y by x is variable, y by x keep on changing. So if I am representing it through vector, then y by x should be present there because it is variable there. Basic mathematics. So xi plus y is j, that is the vector representation. I take out x. It becomes I plus y by x j bracket close into x. Okay. Now, if we see the calculus, then division I can convert into differentiation provided numerator is dependent upon denominator and denominator is independent component. Y by x, y is function over x. So it is dependent upon x. X varies, y will vary. Y by x is a fit case to say dy by dx. Now we have again now I plus dy by dx j bracket close into x. The first term I plus dy by dx j is a function over x because dy by dx will come as x only. Function over x fx into x fx into x multiplication of dependent component into independent component will turn into integral calculus. So net representation of the curve vector is 1 I plus dy by dx j bracket close into dx or I plus delta y by delta. Okay, understood. Thank you very much. What about the IS section? We're talking about IS section, right? We're trying to calculate the summation of this by cutting into n part. What is the length? What is the your great length vector of the IS section? Length vector will address full smoothness of the curve, not the straight line, full smoothness of the curve. For IS section, how much it will be? Tell me. That will be I plus delta y by delta x. Okay, delta y by delta x of the IS section j bracket close into delta x of the IS section. Make sense? I plus dy by dx j into dx, that is the length vector. For IS section, it will come as I plus delta y by delta x for the IS section j bracket close into delta x for the IS section. Okay, this is for your IS section. Yes, this is the variable vector. This is variable vector means it will address the curve. Okay, now tell me what is your concept now. Concept is summation of I equal to 1 to n. I equal to 1 to n. Okay, thank you very much. And then IS section length of this vector. Summation I equal to 1 to n, length of this vector. IS section vector. Length of this IS section vector. Length of this IS section is length of this vector. What is the length of this vector? Vector is I plus delta y by delta x of the IS section j bracket close into delta xi. Whatever, this is a vector. Whatever vector comes its length, then add it for I equal to 1 to n. Okay, now this is a kind of, let's see that what it is. Let's see what it is. Now we have, if I take the magnitude of this delta x of the IS section will remain outside only. Now we have vector that is I plus delta y by delta x of the IS section j. Magnitude of this, it will come as 1 plus delta y by delta x or dy by dx, what we will say anyway. Right now it will be 1 plus delta y by delta x whole square. Is it the same as? Certainly. At the end it will come same when result, but this has bigger effect that we will see in the future. It has very powerful effect, that is length vector. But anyway, we are in discussion of summation to integration. So summation I equal to 1 to n and length of this vector. The length of vector, that is I plus delta y by delta x of the IS section j. Length of this, that is magnitude of this. That is 1 square plus delta y by delta x of the IS section whole square root into delta xi. Now I can proceed the way I proceeded earlier. But the concept is different. It came from the curve vector only, not the straight line and then base and square. in not in that fashion. Okay, this will give the whatever we expect, that is 2 pi a. What is this? Okay, now what, tell me, what is the area of a circle? What is the area of the circle? Area of the circle, again, if this is radius, I can chop this radius in radius, I can move this radius into 2 pi angle. Means this, this is, if this is the radius, and if move from here to here, it forms one area. From here to here, it forms area. From here to here, it forms area. If I divide this area into n parts, then again, the what is the area? Area is summation I equal to 1 to n, area of the ith section. What is area of the ith section? There is problem. If I go with the bookish way, what is the area of the ith section? Then there are many ways. What bookish ways and our way through vector, there are many ways I can calculate the area of the ith section. Okay, area of the ith section. This is the this is the this is the radius. This is the radius. This is the angle. Area. This angle is delta theta I ith section. What is area of this? Generally, people find that it is r into this. Considering this is a straight line, then this length into r. This length is r into delta theta I. That is a straight line. I'm sorry, this is r into r delta theta. R delta theta I will give this length. Considering this is a straight line, then it will form a rectangle. This side, this side, this side, this side. Length into width will give the area of rectangle. By half will give area of this triangle, right angle triangle. That is 1 by 2 r into r delta theta I. That is 1 by 2 r square delta theta I. Now it will be summation I equal to 1 to n 1 by 2 r square delta theta I, ith section area. This is the, now we can proceed again from here. If r is a function of theta, like r equal to cos theta, that also draw a circle that many times we have seen. Consider a function called r equal to cos theta. Considering this is origin, then r equal to cos theta will bring circle like this, where radius start from the 0 degree, r equal to cos theta, maximum radius. When angle is growing, radius is decreasing, r equal to cos theta. When angle is 90 degree, radius is 0. Radius started from here, started shrinking. When angle is 90 degree, radius is 0. When angle is more than 90 degree, radius is negative. So I'll flip the side so that radius should be positive. Now radius is this side. Even though angle is growing in this side, radius is going in this side for being positive. So it will form a circle. Even though it is like that, then we consider that the area of the eighth section is 1 by 2 r square delta theta I. R can be function over theta. Then I sum it and then we go through it. But what we are talking now, here it makes difference. What is the net area? Net area is summation I equal to 1 to 1, I equal to 1 to n, area of the ith section. This is the where everything is same. What is the area of the ith section? Ith section area is this area. This area, if I see, then this area is cross product of this vector, and this vector. If I take cross product of this vector and this vector, I get the area underneath it. It may be parallelogram or whatever. Then I have to divide by 2 because there is another one, but whatever it is. I won't consider this is a straight line. I consider this is a curved line. What is the equation of curved line? I plus dy by dx or delta y by delta x of the ith section j into delta xi. This is the vector. What about this vector? What about this vector? If I know this vector, somehow, if I know this vector, cross product of this vector and this vector will give the area of the ith vector. Okay, so if I say, consider this is the, for time being, it, for time being, okay, for time being, it looks like the radius vector. If I go in the polar coordinate system, then it looks like it is a radius vector. If I go in polar coordinates, no, I don't want to go in polar coordinates. Go in Cartesian one. If I move in Cartesian, then this vector, representation of this vector is I plus dy by dx j into delta x, dx or delta x, whatever understanding. I mean delta x is variable. If I take this is a straight line. What is this point? Consider this point is x comma y. This point is x comma y. Then this vector will be I. This vector will be xi plus yj. Xi plus yj. Since this is a straight line, I can proceed xi plus yj. But that is not the concept. Concept is to bring into length vector. Okay, here I will take out y, considering y as variable, because we are trying to calculate area, right? Now it will become as dx by dy I plus j into dy delta y. If I do cross product of these two, if I do cross product of these two, one is I plus dy by dx j, dx cross product dx by dy I plus j dy cross product. This will give the area of the ith section. Then sum it and get the integration. Makes sense? This is completely different concept. We'll proceed on this. This, if someone understands this concept, no need to go for any approximation. Consider this. There are many lochas here. Doing the ith section area, there are many locha here. Okay, no need to go for any locha. Someone can just go with the length vector, calculate the cross product and do it for ith section and then sum it and bring it to integral calculus. You have the result. Amazing, mind blowing. That way, this is not mentioned in any of the book. Please mind supporting us or please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.